enveloped by peritoneum. It has intraperitoneal position. Intraperitoneum. The capsule beneath visceral peritoneal sheath is called Grisson's capsule. And the main unit is classic of the parenchyma is classic hepatic lobule. In the center of each lobule, the vessel is called central vein. From this vein to the periphery of the lobules radiate plates formed by hepatocytes. These plates are called laminae. Lamina means plate. Lamina means plate. Plates, laminae in plural, or plates formed by hepatocytes. But this is one plane, cross-section of the parenchyma. You have to imagine that all plates are interconnected, and there are space between this spongy-like substance of the parenchyma. These spaces are sinusoids, hepatic sinusoids. The spaces between plates of hepatocytes, these spaces are hepatic sinusoids. These sinusoids are discontinuous type of blood vessel. There is continuous type, and these are discontinuous type of blood vessels. Discontinuous means that there are gaps between endothelial cells. Endothelial cells are simple squamous epithelium, covers the wall of blood vessels. It doesn't matter the type of blood vessels. Artery, veins, capillaries, all blood vessels and lymphoid vessels also are lined by simple squamous epithelium called endothelium. Do you remember this type of epithelium? Endothelium is the name of epithelium. Endothelium. Artery, veins, capillaries, they possess continuous type of endothelium. It means that endothelial cells are interconnected by tight junctions. But here, sinusoids are unusual types of blood vessels. They contain blood, obviously. Unusual type, discontinuous. Discontinuous type of blood vessels. It means that there are gaps between endothelial cells. And sinusoids between plates of hepatocytes receive blood from two vessels. The blood supply of the liver is extremely unusual because two blood vessels enter the parenchyma of the liver. 80% of the blood is the blood from portal system, vena porta. only 20% rich, oxygen-rich blood is the blood from arteria hepatica propria or proper hepatic artery. Do you remember something about these two blood vessels? Previous class we mentioned arteria hepatica propria is a branch of common hepatic artery. Common hepatic artery, branch of celiac trunk. We mentioned previous class the blood supply of small and large intestine and the blood supply of the stomach. The first unpaired branch of abdominal aorta is called truncus celiacus, celiac trunk. Truncus celiacus has three branches: common hepatic artery, left gastric, left gastric, common hepatic, and splenic, arteria renalis, splenic, because spleen or spleen. These are branches of celiac trunk. Branch of common hepatic is proper hepatic artery, this artery. Common hepatic artery has two main branches: proper hepatic and gastroduodenal. Gastroduodenal in turn divides into superior pancreaticoduodenal artery and a right gastroepiploic. We mentioned these arteries previous class, do you remember? Right and left gastroepiploic are located on the greater curvature of the stomach, left and right gastric on the lesser curvature of the stomach. Today we will start learning the branches of abdominal aorta during the dissection. And two blood vessels enter the parenchyma: vena porta poor in oxygen but rich in different metabolites that are absorbed in stomach and small intestine. And arteria hepatica propria, oxygen-rich blood. And these two vessels divides repeatedly, and finally their terminal branches are located here between classic hepatic lobules. For example, here. And terminal branch of vena porta is called vena interlobularis because its terminal branches is between, therefore inter-adjacent lobuli. Vena interlobularis. Terminal branch of proper hepatic artery is arteria interlobularis, vena arteria, and the blood from these blood vessels flows to the direction of sinusoids. Therefore, sinusoids contain mixed blood, venous and oxygen-rich blood. Do you understand? This is unusual blood supply. Because all metabolites coming from portal system enter the hepatocytes. There is processing of these metabolites. Maybe you discussed during the course of physiology the role of hepatocytes. They produce what? Lipoproteins, albumins, fibrinogens. This is the tasks for study during the course of physiology. But hepatocytes are, you know that 25% of hepatocytes have two nuclei. They are binucleated cells. They contain numerous mitochondria, smooth endoplasmic reticulum. They participate in process of detoxification also, and also they produce bile acids. Different role have hepatocytes. Terminal branches of vena porta, arteria hepatica propria empty into the lumen of the sinusoids. In opposite direction is the bile secretion, because hepatocytes also secretes components of the bile. Initial part, one of initial parts of biliary tree are ductuli interlobularis, near to the terminal branch of the vena porta and arteria hepatica propria are ductuli interlobularis. And these three structures together constitute triads of Glisson. Triads. These are triads. And hepatocytes, these cells usually have 5 to 6 walls, but they are arranged by three types of surfaces. Every moment, one of their surface faces to the wall of sinusoids. Imagine this is the lumen of sinusoids, and these are endothelial cells. This is the lumen. Sinusoids. And this one, hepatocyte, and its nucleus. These are nuclei, for example. These are adjacent wall. Here, cells are interconnected by tight junctions. There are junctions between cells. Junction, and part of cell membrane, hepatic cell membrane, participate in forming the wall of the smallest bile ducts called canaliculi biliferi. Their wall actually is formed by the membranes of hepatocytes. Canaliculi biliferi. Canaliculi biliferi they are devoid of their own wall. Their wall is formed by the membranes of adjacent hepatocytes. And here, in the lumen of this canaliculi biliferi, hepatocytes secrete bile acids. Do you understand? And bile secretion flows to the opposite direction of the blood. Canaliculi biliferi are united to form so-called herrings. Canaliculi, and they in turn are united to form ductuli interlobularis. But you have to know, not these intermediate forms. The smallest bile ducts are canaliculi biliferi between hepatocytes. They are united to form larger bile ducts called ductuli interlobularis. One of the wall of hepatocyte participates in forming of the wall of canaliculi biliferi. The other wall of these hepatocytes, for example, is faced to space called this. This is the space of cell membrane, the cell membrane of hepatocytes, and the wall of sinusoid. And here, hepatocytes, the membrane of hepatocytes form numerous microvilli. They are indicative, they are a sign that there is highly active transport from and to hepatocytes. Because the lumen of sinusoids, here, there is blood from portal vein. And there is process, they uptake, these hepatocytes uptake all metabolites located within the blood. Do you understand? You have to know that the hepatocyte, the shape of hepatocyte is so-called polyhedral. It means numerous wall. Numerous, 5 to 6 walls, irregular in shape cells, but 3 types of surfaces. One to the face is to the canaliculi biliferi. The second type to the space of this space between hepatocytes and the wall of sinusoid is called disse. And the third type is the wall to the adjacent hepatocytes. There are different types of contacts here. tight junctions, gap junctions. And this surface is responsible for forming these plates or laminae around the central vein. The lower surface of each globulus, central vein exits, and here this vein is called sublobular vein. Central vein are united to form the other structure part of blood vessel, venas sublobularis. Sublobular because they are located at the bottom of each lobulus. Venas sublobularis. Venas sublobularis are united and finally they form vena hepatic vein are tributaries of vena cava inferior. Vena cava inferior. Do you understand? Two blood vessels enter, divides. The blood passes, mixed blood in sinusoids, then to the direction of central vein. Central vein are united to form sublobular because they are located beneath the lobuli. Sublobular are united to form hepatic vein. Hepatic vein drain into inferior vena cava. This is the blood circulation of the liver. Do you understand?